All right, so L'Hopital's rule. This first example is not L'Hopital's rule. That's just a regular old limit. Plug it in. As long as you don't get 0 on the bottom, all is well. Now, if you do get 0 on the bottom, then the answer is probably infinity or negative infinity. But if you get 0 on the bottom and 0 on the top, or like a combination of zeros and infinity, that's what we call indeterminate form. And that's when something else has to be done. And earlier this year, so I'm now reading from the packet, we evaluated some indeterminate forms by algebraic techniques. So, well, first you don't even know it's needed until you plug it in. So that'd be 2 minus 2 is 0. Negative 1 plus 1 is 0. So you'd say 0 over 0 is indeterminate. Therefore, I've got to do something else. So 0 over 0 is not an answer. It's an alarm that something else is going on. So let's do some algebra. This one's not bad, because the top will factor into x plus 1, x minus 1. And then the x plus 1's cancel. And then we try again, basically. Limit as x approaches negative 1. 2 times negative 2 is negative 4. So 0 over 0, there was probably a hole in this equation at negative 1, but the y value of the hole is negative 4. So the limit is negative 4. Number 3, if you plug in infinity, you get infinity over infinity. And
that's not good.
I should not have put the equal sign on that first one, because it's not equal to 0 over 0, because 0 over 0 isn't really
Incorrect.
a thing. Incorrect. So leave off the equal sign, write infinity over infinity, and then say is indeterminate.
Or you could just put the slash.
Or you could do what I did and be like, whoops, that doesn't really work, so not true. Do you remember what we do on number 3? There's kind of a shortcut to that one.
If the exponents are equal, you take the coefficients of the limit.
Yeah, if the exponents are equal, like as this gets really big, then the only thing that matters are the 3 and the 2. And so this is 3/2. That's sort of the top no, bottom O equal co.
Pardon?
Top no, bottom O equal co. That's
I don't remember that.
Top no, bottom no equal code.
as x goes to infinity, you can use that little
What's top no?
top. If the top is bigger than the bottom, there is no limit. If the bottom's bigger, then you're headed towards 0. And if they're equal, meaning the coefficient or the powers are equal, then you use the coefficients.
Oh, that makes sense.
Cosine. I was like, what?
Coefficients.
You confused us.
I don't really want to do all of the
Different ways.
all of number 4, except to set it up. I'm guessing I get 0 over 0. 3 minus 3 over 7 minus 7. 0 over 0, which is indeterminate, and I'm avoiding the use of equal signs because it's not equal to 0 over 0. This was long, long ago.
Mm-hmm.
Do you remember the algebra steps to fix that one?
You would multiply by square root x plus 2 plus 3.
Multiply what by?
The top and the bottom.
Yeah, you. So you multiply by the conjugate. And that would fix things, basically. We'll leave it alone. Basically, the top turns into x minus 7, and that cancels with the x minus 7 in the bottom, and then you're able to get an answer. dot dot dot. There's a better way though, so we're going to leave that one alone. Not all indeterminate forms can be evaluated by algebraic techniques.
Which is frustrating.
So if we plug in 0 for this one, sine of 0 is 0. That's indeterminate. This is one that we are supposed to have memorized, but goodness, it's been a long time. Do you already remember what that one is? If not,
No.
it is one. But hold that thought, because there's a we'll do it a different way in a moment. L'Hopital's rule. To evaluate limits which result in 0 over 0 or infinity over infinity, so it's got to be one of those forms, we can use a technique called L'Hopital's rule. It only works for those two indeterminate forms. And I mean, that makes sense, because 0 over infinity, that's just going to be 0. So, like, you don't need that. It's when you can't figure out how it reduces that L'Hopital will work. Don't use it for everything. Here's L'Hopital's rule. If the limit results in the indeterminate form, then the limit equals the limit of the derivatives. Not the quotient rule. You're not doing a quotient rule thing. You're just doing derivative of the top, derivative of the bottom. And the limit is the same. So it's really useful and easy. So number 5. Plug in 0, you get 0 over 0. That doesn't work. So let's use L'Hopital's rule. Going to abbreviate that LH. So the derivative of sine is cosine, and the derivative of x is 1. And then we try again. So plug the 0 in. Cosine of 0 is 1, and 1 is equal to 1. So that answer is 1. So even if you didn't have that one memorized, no big deal. One step L'Hopital and you're good. Number 6. Always first go on limits is plug them in and see what happens. Limit to negative infinity squared. Oops, put that in the right way. Negative infinity squared would be positive infinity. Like a bigger infinity, but still infinity. Over e to the negative infinity. Which is e to the infinity, which is...
really small number. Well, it would make it out of really
The
small.
two negatives make it a positive. E to the infinity is a really big number.
But if you made it, like, if you worked out the fraction, it would be a small number.
How do you know? Because both of these are going to be big numbers. Big
True.
over big. We don't know which big is bigger.
True.
So this is eligible for L'Hopital's rule. So derivative of x squared let's see. We can do these. Brooke, no pressure. What's the derivative of x squared? 2x. Logan, you get the harder one. What's the derivative of e to the negative x?
Don't worry.
E to the derivative of e to something. E to the something
Times the something.
times the derivative of the something.
Oh, yeah. Drop D1.
So let's try again. Now let's plug in negative infinity. Again, I'm trying hard to avoid using the equal sign because I know it's not exactly correct. So this one is negative infinity over negative infinity. That's still kind of the same issue. But we're getting better because our numerator went from x squared to 2x. So let's use L'Hopital's again. And then as x approaches negative infinity. Here we go, Logan. You can redeem yourself. What's the derivative of 2x? 2. And the derivative of e to the negative x is still e to the negative x times a negative 1, which makes it a positive 1. All right, let's try again, plugging in negative infinity.
Is that acceptable?
So 2 to the negative infinity is 2 over e to the negative infinity is 2 over e to the positive
Is
infinity.
that good?
I think that's good because
That's a number.
what's e to the infinity?
Really big.
Really big. What's 2 divided by really, really big?
It's really, really small.
So that one's 0.
We can just assume that there? Or?
That's not even an assume. As x gets bigger and bigger, the bottom is getting bigger and bigger. The top is still just 2. So 2 divided by a big number is small, and 2 divided by a bigger number is smaller. And 2 divided by a bigger number is smaller.
Smaller.
And then you keep doing that, and you're approaching 0. Number 7. Limit as x approaches infinity of this thing. So natural log of infinity squared. I'm just going to write this as over infinity like that. Natural log. That looks like that. So as the argument gets bigger, the natural log gets bigger. So infinity over infinity is indeterminate. I'm going to just rewrite this because it looks funny. Natural log of x squared over x. All right, now let's do something before we use L'Hopital's, I think.
Slip the 2 out front.
Yeah, let's take the 2 out front. Make life a little easier. So I still haven't used L'Hopital's. In fact, I could have done this first. Maybe should have done that first if I was paying attention. So now let's use L'Hopital. 2's still there. Dare I call on somebody for the derivative of natural log of x?
And then I'm into here.
What is it?
1 over x.
1 over x. And the derivative of x
Is 1.
is 1,
Which makes it 1 over x.
which makes it 1 over x.
2.
The 2 in front of it won't really matter. Oops, I don't want to do equals. Oh, actually, I think equal would work on this one. 2 over infinity. 2 divided by a big number
It's a super small number.
is a super small number.
Itsy bitsy.
That makes sense.
Okay.
So, L'Hopital's rule: if you got a fraction that's 0 over 0 or infinity over infinity, take derivative of the top, derivative of the bottom. Don't get it confused with quotient rule, and try again. Yeah, we're still good.
I just wasn't sure. I knew it was a weird schedule. We're gonna do 8 first, or?
Let's do 8. Why don't you try 8? I mean, first go would be 1 minus 1 over 0, so it's indeterminate. So take derivative of the top and derivative of the bottom and see what happens. I'm going to press freeze and pause, and then we'll compare answers. So derivative of the top, derivative of the bottom, and then plug in again. Looking at number 9, I'm sure you get 0 over 0 because tangent of pi over 4 is 1, and sine and cosine of pi over 4 are the same thing. So this is another L'Hopital's problem. We're not going to do 9 and 10, by the way, or at least the second 9 and 10. So this will be our last example to worry about. So you try number 9.
Which number 9?
The first number 9. Ooh, derivative of tangent is
Secant squared?
secant squared. And then, kind of off to the side, I was trying to figure out what the secant squared of pi over 4 is. So had to find the cosine of pi over 4. Had to flip it over. And then when you square it, you just get 2. So that's good. So the top is just 2. And then the bottom is root 2 over 2 plus root 2 over 2. Which is 2 root 2 over 2.
Which is square root 2.
And then 2 divided by root 2 is root 2.
Wait, hold up, what?
Wait.
Why is it root 2?
Because 2 divided by root 2 is root 2.
That doesn't make sense, why?
Because you would multiply the top and the bottom by the square root of 2.
Oh, okay. That makes sense.
Sort of want to prove it to yourself. Yes, sir?
So, you found the cosine of pi over 4.
Yes.
And then you found so secant pi over 4. Would that be? So secant pi over 4. I found secant squared pi over 4.
It's 2.
It's just 2. Okay, yeah.
Yes.
I'm good. Yeah, that makes sense. I just overcomplicated it.
I was showing more steps than you, perhaps.
Yeah.
Okay, so we can skip 9 and 10, and then the assignment, let's just make it the odds. That's a lot of problems. Although they do go quick because,
Once you get the hang of it.
again, these is not quotient rule problems. These are just simple derivative
Which I think
problems.
before.
So, like, try number 1. We still have 10 minutes left. You guys
I
are
know.
eager to go. So try number 1 really quick.
When Monday after spring break, you expect us to be excited?
Pretty much guaranteed.
No.
So what you're saying there's a 30.
All right, so try the odds. Tomorrow we will we'll shift to review mode.
I'd much rather invest in ideas. I'm investing $1,000 in a boat idea or a great idea. How about
Then you're gonna have to share the time.
Let's do it. Isaiah, I will actually do it.
Because I put on sunscreen, but I had a shirt on under my swimsuit. Like 10 minutes before we went to the beach.
4 hours.
Snack guys.
I have no idea.
Were you like whoever invented algebra? Right, he's on the road. Like think about it.
Preston, you're
Negative numbers going to zero.
Bro, we get like 12 dudes. I
Have you ever Star Wars?
It's like it's like angles and shapes.
I saw
get it. Like the theory.
horsepower down. You don't have right now.
Wait, so what's the point about
-1.
This doesn't work.
Mr. Wolf, when's the latest I can take this test?
We're about to buy a
I just need to learn enough to do like 50,
scam
so
boat.
I'm
It was like no
scam.
scam.
Right, so you should be fine, but
We should get
It was
a.
like a $15,000 boat.
I mean, technically I could get a 30 and still pass, but 50 is more comfortable.
Get some money on my
so when can you take it?
I mean, preferably Wednesday, but if it has to be done tomorrow, I can grind tonight.
I think you can do it Wednesday.
Okay.
You'll be okay.
I'll still like practice tonight just in case.
Wednesday's fine.
Okay. Sorry, we don't have Mustang hour.
We don't have Mustang hour, so
Like 2 hours. I was
So
like,
morning.
do you have
I don't.
do you have Stuco something or
Fifth
other?
period. Fifth period.
Can you fifth period?
Yeah.
You tell JMO that you're taking a.
Right. She doesn't fit. Fifth period Wednesday.
She took you out of class, so
Yeah.
she's gonna have to cut. Yeah.
Do you know this girl? Do you know like you?
Yeah, I know her.
How do you know?
I met her.
Dude, if you're talking to other girls, you're sure she You're a great guy.
Thank you. People don't think I'm a great guy.
He's a great guy.
Second period tomorrow since someone's schedules on this.
Yeah.
Okay.
That'll be fine.
Running games. Thank you.
You're welcome.
Sorry, I was just being relieved.
in 67 days, it took
If you get a little gust,
No, you're not.
No, I'm not. I'm right now.
it's fun because when you get a gust right after you take off, you like move because you get really
Wait, are we? Hey, someone else have is that the same reason? You're the friend. It's all big movement. It's not First of all, those are Isaiah. And then
What is this for? Just
We don't like it. Look at I didn't have time to teach you because I was working